Hello everyone, welcome to the weekly lecture videos once again. In this video, I'm going to discuss the third learning objective of chapter 4. So let's start with discount rates. If you look back at the expressions we came up with for the present values and future values in the last two videos, you will see that there is a very simple relationship between the two. Between the present value and future value. So in this video and the next one, we are going to explore this relationship and some related issues, okay? As far as the discount rate is concerned, we frequently need to determine what a discount rate is implicit in an investment, right? So for example, if this is our future value equation, if we know the future values and present values and the time period, and we want to know what the discount rate is, we can simply find it out by rearranging this equation. Okay, so you can see the discount rate is present value divided by future value power 1 by t minus 1. Okay, this essentially, the R essentially is the rate of return or the required rate of return associated with an investment where a certain present value grows to the future values over the time period at this discount rate. So look at this example. If you put up 1,250 for 1 year, you will get back 1,350. What is the rate in this investment? So you can see we are given with the present value, we are given with the future value, and the time period is 1 year. We need to know what is the rate the investment is paying. So straight away, we use the formula that we have seen in the last slide. So R equals to future value divided by present value power. You remember 1 by t, so t is the time period, and minus 1. Okay, and if we solve for R, we find that the rate of return associated with this investment is 8%. Or in other words, we can say that if we put up 1,250 this year, earn 8%, this will give us 1,350 at the end of the year. A similar example, you have been offered an investment that promises to double your money every 10 years. What is the approximate rate of return on the investment? So once again, you need to calculate the rate of return on investment. However, instead of the present values and future values given, we are given an information that the investment's nature is such that it will double the investment in 10 years. So in this case, we use a rule which we call Rule 72, okay, where the rate of return is calculated as 72 divided by n when the investment is supposed to be doubled in a certain year. So you can see 72 divided by 10. 10 is the number of years by which the investment is supposed to be doubled. And if we solve for R, we find that it's 7.2%, which means that an investment will be doubled in 10 years if that earns a return of 7.2%. Now we can check this. So you know that rate of return formula is future value divided by present value power 1 by t. So let's say we are investing $1, so it will be grow to $2 because it will be doubled, and 1 by 10, which is the time period. And if we solve for R, we find that it is 7.177%, so which is almost equivalent to 7.2%. Okay. Another example, we estimate that you will need about 80,000 to send your child to university in 8 years, and you have about 35,000 now. If you can earn 20% per year, will you make it? Okay, so in this case, what do you want to find out? You want to find out the future value, that First of all, 35,000, which you have now, interest rate is 20%. So in 8 years' time, your money will grow to 150,493, right? And you require 80,000 to send your child to the university in 8 years. However, you see that your investment grow to 150,000 when you earn 20%. Okay. The next question is at which rate will you just reach your goal? So obviously in this case, you can see that your money will be more than enough you need to send your child to uni. So in this case, what you do is you need to find out what is the rate your investment will be making just enough money for your child to go to uni. So once again, we use the same formula, future value divided by present value into 1 power 1 by t. So 80,000 is what we need. 35,000 is what is invested. And you can see that 10.89% is the rate which is needed for the investment to grow just enough for the child to go to uni. Okay. This is the last example in this video. You would like to retire in 50 years as a millionaire. If you have $10,000 today, what rate of return do you need to earn to achieve your goal? So once again, it's a rate of return problem. You have $10,000 today, but in 50 years' time, you want to be millionaire. So you need to find out what rate will help you achieve your goal. So once again, future value divided by present value power 1 by t, and you can say it's 9.65%, which means that if you are 9.65% and invest $10,000 today, in 50 years' time, you will be a millionaire. Okay, so that's the end of this video where we learned that how the simple expression of present value and future value can be rearranged to find out the rate of return on an investment. Okay, so thank you very much.